because it starts with lambda. It starts with lambda. And for that, with that function, you would have a new expression n. I'm just gonna call it n for name equals name x, and you would also have a assume that I've actually put a new there and actually know how to write code. And then for the second x, it would be an hang on a second, I messed up. Yes, you'd have so that would be so the first x would be the name. Second x is the expression, right?
Yeah, that's right.
I feel like I'm confusing myself a bit here.
Yeah, because function has two members. It has a name and an expression. Yeah.
Yeah.
And the name's called variable and the expression's called body. That's right. So yeah, you're probably going to have a constructor, something like this. So I've called this thing I because it's the identity function. So I'm going to define I. It's a new function, but it takes two arguments. And we're assuming that the first one goes in name variable and the second one goes in expression body. Okay?
Yeah.
So the key point here is you don't need to write a parser because you could just create your whole Lambda expression using constructors like these and forget all about the parsing step. Yeah?
Mm-hmm.
In fact, shall we actually do this? Let's do, shall we attempt a little bit of live coding even?
New project?
Yeah,
that always works tremendously. I've never seen live coding ever go wrong in my life.
No. There is one place where we have had live coding, and I'm pretty sure we've all seen it. And that's when we were doing machine learning. And it worked really well.
Right, okay. I don't want to do this in C. Can I do this in Python? Right, let's just have a little look
very easy. Yeah.
at what this looks like. Okay, so new file. Yeah, start from scratch. Right. So let's create that class. What should we have first? Class name. Right.
Mm-hmm.
And class name is going to have a constructor with a self and an ID. Yeah. And all this is going to do that highly redundant colon that's needed at the end. This is going to need to say self.id equals ID. It's just going to store the ID. Okay?
Mm-hmm.
If that actually works. So now I'm going to say x equals name. I'm going to give it a string name. Okay? If I do, what did I call that thing? ID. I can go in there and inspect the string. All right?
Mm-hmm.
Okay. So what do we want next? We want to say class. Should we do functions?
Mm-hmm.
Oh.
So for that, we need to start with we need to have a variable for name and a variable and an expression for body.
Did we call that? Did we call it variable? Sorry.
Mm-hmm.
Yeah, variable. This is Python, so a lot of that carefully thought out subclassing is going to be fairly invisible. Can I do that in Python 3 nowadays? Does it let me do that? Body needs to be a.
There's something in the standard library that allows you to do type hinting. Yeah.
Yeah. Okay. I don't actually. Okay. If you're in a type language, you're going to need a bunch of that stuff. It's hopefully easier in Python. Or harder, depending on your point of view. Right. So once again, we're just going to say self.variable self.body equals body. Right. So for example, we can now make,
I was just thinking with the self.variable bit, you could do it as self.variable.id, so it actually gets the actual name ID which you were trying to pass in.
no, we specifically don't want the names. We want the actual structure at this level.
Itself. Okay.
Yeah, we're specifically getting away from the syntax and making the parse tree. So at this point, then I should be able to create function, right? So this is the identity function. Doesn't do anything yet. I can say what's the variable. Let's take a look at the ID, and I can say what's the, what did we call it? What is the body? Okay. So this is the function that takes X as an input and it returns it. And notice we haven't told the system how to do that yet. We haven't told it how to evaluate. We're only building the data structures. Yeah. Okay. So what else do we need? Application. Yeah.
Yes. So for an application, we wanted an operator, which would be, if we were doing class definition, if we were doing type definition, it would be just an expression, and we'd have a second expression argument.
Sorry, operator and argument. Yeah.
Operator and argument.
Yeah. Sorry, I just figured out my bin configuration the other day because we were looking at weird things. That's why you've got all these things getting highlighted. Sorry, so we've got an operator and an argument.
Yes.
Okay, so once again, for the constructor, we'll just put in that, and for the argument, we'll just put in that. Okay. So at this point, I can start writing an actual program using these things. So I'll say X is going to be the name, Y is going to be a name. For the Z as well, then we're done. Okay, let's say I equals a function which takes X and returns X, yeah? And then let's say big A is going to be an application which takes the identity function and applies it to X, right? Okay, so you now have an application structure. So let's look at what is the operator of A. So that's a function. If the function has a, what did we call this thing? A variable. Let's go and look at what is the variable. And it has a, what do we call the other thing? The body. No. What did we call the other bit of a function?
The other bit of a function.
Body, yeah, body.id. There you go.
Yeah.
So A is now existing as this tree structure. Yeah. So at this point, you have all the data structures that you need to represent the interpreter. So you don't need to write a parser because you can just construct all your expressions programmatically like this. Yeah. Okay. So actually, I'm not going to apply it to X. I'm going to apply it to Y. So I don't want to muck about with alpha conversion. But there we're going to apply the identity function to Y. Okay. Okay, so next job then, we need to do some evaluations. Okay, we need to actually do stuff. Yeah. So what should we do? Let's make this up as we go along. For an application then, what should we do? Let's make an eval function. All right. So traditionally, evaluations are always called eval. So the purpose of eval is to, what exactly is this going to do? We're going to call it on the application, and it's going to do the application, and it's going to return an expression that is the result. Yeah?
Yeah.
So how are we going to do that? We know what our operator is, and we know what our argument is. So we're going to take the argument, and we're going to hope that the operator is in fact a function at this point. Yeah.
Mm-hmm.
If we had types, this would be easier. Okay. And this thing is an expression. So to evaluate it, we're going to take the argument and we're going to put it into the function and possibly ask the function to do the substitution for us if we're being nice and object oriented. Yeah.
Mm-hmm.
So maybe we'll do something like return self dot operator dot make substitution for the argument. Yeah.
Mm-hmm.
I've passed the buck here. Yeah. I just said go and make the function do something instead. So now I've got to go and put something in the function. Okay. So we'll do. Let's make a make sub. Make sub method. So this thing is going to take an argument now. Okay. So roughly, let's write this in English first. What we're going to do, we are going to inspect the body and replace variable with argument. Yeah.
Okay.
So that's right. Now the body could be anything, couldn't it? The body could be a whole tree because it's an expression.
Yeah.
So this is going to have to be recursive now. That means everything is going to have a make sub.
Oh God.
Right. And what do we need to do a substitution? You're always going to have to propagate this variable around, and hang on, let's get this the right way around. When you make a substitution, there is yeah, we might need an extra layer of functions. So when you make a substitution, there is something that is being substituted, as in being gotten rid of, and there's something that is doing the substitution. Yeah. So at this point, are we only ever dealing with names? The only thing that is being substituted is a name, right?
Yeah.
We're never going to substitute a whole expression for anything.
So we're going to want an old name and a new name.
You're substituting with an expression.
The expression.
Okay.
And
Okay.
then.
So if you're doing this on a name, so let's say you've got a node that is just X, yeah? So it's very simple. This is the bottom layer of the recursion, right? So you're going to say if self.id equals old name, then do something, yeah?
Would you want if self? Yeah. I was gonna say, would you want it to replace the ID with the new expression, or do you want to maintain?
So look, at this point, class name is a type of node in that tree, yeah? If you've got X in your tree, then you're going to replace it with this whole expression XYZ, yeah? XYZ isn't a name. XYZ is an expression. I think at this point you're going to have to put this name in the bin, and you're going to have to return a new expression. Yeah? So the result of substituting a name node for an expression isn't a name; it's an expression.
Okay.
Okay. Good. Okay. Let's think about. The problem is this function signature isn't quite the same as this one, right? You see, this one's got old name and new expression, and this one's got self and argument. So I'm actually let's do the recursive bit first. Now we've figured out that's something we actually need to have. So if we're going to substitute in a function, what happens in the function then? We now have, again, I'm trying to avoid having to think about alpha conversion. Shall we just assume that the thing is always free for now? We'll only do the replacement in the body. Can I get away with that?
Yep.
Yeah?
So so in the function we've got the name variable and an expression body. So
the variable is going to be the same, yeah? We're creating a new function, but the body is now, this is an expression. So whatever that expression was before, we're now going to have to recurse and do make sub. Something like this. Okay, so that's passing the recursion on to whatever was in that expression, and eventually you should get all the way down to the bottom level of nodes. Okay, so we're going to need to do it again for what are we going to do if you've got an application, right?
If you've got an application, we have two expressions. We've got the expression operator and the expression argument. So
what type?
The argument is what we're trying to pass in, right? So argument is going to become the new expression.
Yeah.
So we'll want to return application, and we'll want to return the operator, and then return make sub old expression or old name new expression.
So it's going to be something like this, yeah? We're going to pass the recursion on to both parts of this.
Yeah.
Yeah? And the substitution we're doing is going to be the same. Yeah, so we're recursing on both sides of the tree. Yeah, an application has an operator and an argument, and we want the substitution to occur inside both of them.
Yeah.
Does that make sense? Yeah. Okay, good.
Actually, isn't that the eval logic? So we want to be passing new expra instead of argument, because when we call make sub, we're not trying to evaluate the application. We're just saying go down the left-hand side, go down the right-hand side, replace all instances of old name with new expra. We're not trying to replace it with the argument. In fact, does this infinitely recurse as it is now?
It'll recurse all the way down the tree, but eventually you're going to hit a bunch of names, and then you bottom out.
Yeah, but this application that you're doing at the moment. So all that we want to do in the make sub function is make the substitution, but because we're using expression, or rather argument as the argument for the substitution, we're trying to substitute argument into argument in the right-hand side of the application that we're returning.
Sorry, where is that?
So yeah, on this line, we want to replace instances of old name with new expra, not with argument. So we're calling a mix-up.
Sorry, I mistyped. I was looking at the init sig for the specification. I copied up an argument. Yeah, I want old name and new express. Brilliant, thank you. So let's put in new express. Ooh, did that actually get caught by this WYSI vim error highlighter thing? It's saying it doesn't know what argument is there.
Yeah, I mean, whatever. IPython is magic, so it does some special things to them. I know.
Actually, didn't. Oh. Okay, good. Yeah, look, those complaints have all gone away. This is a bit too close.
Except where it's saying that your PEP8 adherence is poor.
yeah. Overly zealous linting, I think. Right. Okay, cool. So that's how we make a substitution. So making a substitution isn't the same thing as evaluating. It's just making a
Oh, actually, some of the other complaints that it's making is where self is being missed out in the function class, returning function. It should be self.variable and self.body.
Ah, yes, indeed. Very good, very good. That's quite handy, that thing, isn't it? Right. Yeah. Okay, so now we need to actually
Do we
evaluate
do?
this stuff.
I was gonna say, don't we need to update the return in eval because we've now got more arguments being passed into being used in make sub in all of them.
Yeah, we do, we do. So let's think, is application the only time you ever actually do an eval? If we're not doing alpha
Yeah,
conversion,
that should be
all
the
there
case.
Yeah,
Yeah,
it looks like it.
Application is the only way defined for a function to be applied to something because that's an application. So substitution is just another way of saying application.
Yeah, good. Okay.
I noted down the stuff we'd written on the lecture slide, the sort of class breakdown which we'd done, and in application is the only one where we've got the arguments being passed in.
Mm-hmm.
Everything else is just like a body or a variable and stuff. So I think, yeah.
Okay, cool. So what shall we actually do to make an evaluation then? Yeah, so we sketched this out before, but now we've defined exactly what the sub is. So what we're going to return then is we're going to take that operator, because the operator is the basic thing that's going to come back from this, yeah? So it's the operator that we're going to talk to, but we want to go through the operator and tell it to look at its own variable and do a substitution, yeah? So yeah, we can make a choice here about how to actually express this. So rather than calling it make sub, let's call it something else. Actually, can I eval a? Let's just play with this. If I call that with an eval, then I'm going to pass it my argument. Yeah.
Mm-hmm.
I'm just going to say, here's an argument. It's your problem to go off and do something with it. Yeah. Don't care what you do. I'm just an application. Yeah. You're a function. Go and evaluate yourself using some argument. Okay.
Yeah.
So if we do it this way, we're going to need an eval setting up here. Yeah.
Yep.
And yeah, this feels like a more sensible place. Notice you can evaluate an application without any other arguments, but to evaluate a function, you have to pass it an argument. Yeah, which is
because the application already contains an argument in itself, whereas the function does not.
Yeah. Okay, so at this point, what are we going to do now? We're going to take our body, yeah, and we're going to make a substitution. And
we're going to want to substitute an argument.
So what was the old name? What are we looking for in the body? The variable.
Yes.
Yeah, x. Wherever you see an x, replace it with argument. Right.
Mm-hmm. And then, are we going to need to go back into? Are we going to need to add anything to the name function, or is that now?
So you can't evaluate a name, can you? There's no concept of because like once you take this point, you're only doing make subs.
Yeah.
Okay. Still compile. So let's test this stuff one step at a time. I'm not going to go straight for the eval because there's no way that's going to work. Let's just try doing some make subs. Okay. Mm-hmm. So look, here's x. Okay. So I do x dot make sub. And let's get this right. Wherever you see, this is where you've got to be careful. Wherever you see a name, such as y, we're going to replace it with another name, such as Z. Okay?
Yep.
Yeah. And that should not do anything because there isn't a Y anywhere in it. Can anyone see what the bug is? Yeah, there's going to be a bug here. So that's done nothing. The problem, oh, is it a problem? What? Is this going to barf, do you think? Do you think this is going to work? I'm going to have to pass it itself. If there's a name in it that is actually yourself, then replace it with a Z. Let's see if that actually still works. Right. So that should have replaced the X with the Z, yeah? I think the problem is we're comparing IDs rather than names.
Yeah. How are you actually doing the comparison? Are you comparing with the ID, or are you comparing with? Yeah, you're comparing to the ID. So if you pass old name in as a Yeah.
Okay. Now this relies on the old name definitely being a name. Yeah. That's part of the contract. If you pass in anything that isn't a name there, it's going to barf. Okay, so let's try now x.id. Ooh, why did that one not work? It has the right ID. X.make sub x and z. Any idea why that's not doing what it's supposed to do? She thought that was going to work. Let's have a look. So if my ID is the same as the old name.id, yeah? So that should be
It might be, but it's not returning.
Yeah, it is working actually.
Expression.
It's
not
replacing it
returning
in
Z.
a
It's
variable.
returning the.
Oh, it's returning a new thing, isn't it?
Yeah, so it is returning it. So that main.name that you're looking at is good.
Hey.
Yeah. Okay. Good. Not going completely crazy. Okay. So hopefully that name is all working then. Yeah, we can make a substitution in name. So what should we do now? Should we try making a substitution in a function? Yeah. So let's say, and again, I'm just ignoring alpha conversion here because we don't want to get into all that. So I don't want to do this on the identity function. Let's make another function to play with. Right? Let's make something called f, and what could this do? It could take an input x and it could put a y on the end, right? Yeah. So let's do it like a proper language. Let's call this thing add y, right? Add y is a function that takes an input. Ooh, that's not quite right, is it? It's going to return an application like that. Does that make sense? Happy?
Yeah, but you defined your application in such a way that the operator always needs to be a function itself. So actually, if it was an application, oh yeah, well, we don't know what x is going to be yet, but we're giving it x at the moment. So actually, we do know what x is because x is just a variable. Maybe add y would be better if we use our currently existing function. If we use I, so get ID of y. So yeah, we're trying to get the ID of y. Okay. So we're replacing it with a even. Yeah. Oh, well,
I'm not going to call this x then, because remember I is all defined using the letter x. Yeah. So let's introduce yeah, sorry, y. Yeah. Okay. So add y. It's not really add y anymore, is it? What should we call this thing? IY. This is a silly function that takes input y and it applies the identity function to it. Yeah. Just check everything is happy there. Good. Okay, and the reason we've done that is to test substituting things in functions. Yeah. So if we do I dot, probably at this point you want a little thing for pretty printing. Okay, pretty printing means making things look nice on the screen. It's always called PP. So if you print a name, we're going to return a little string yourself.id, right? If you print a function, you're going to return Lambda that returns self.body. Yeah. And if you print an application, how should we do an application? Should we put it in brackets? Let's put the operator in brackets. Something like that. If I do pretty print identity function.
Doesn't that, yeah, that needs to be because it's in the body rather than a function itself. Yeah.
Concatenate a string.
Yeah, you're not calling the pretty print on it. It's a variable.
Everywhere else.
Yeah, that PP needs to be.
Yeah, wouldn't you have to write that as self.variable.pp rather than pp
Oh,
self?
yes. Very good.
And you need to do that in the
Here.
that one.
Okay, there you go. So now we can print my y. There you go. If I just have a single variable. Okay. Got lambda on there. Got a buck in it.
Huh.
Lambda. It's lamb like a sheep, isn't it? Lambda.
Yeah. Like it's definitely complex, but it's not as complicated as I thought it was going to be.
Yeah, good.
Huh.
Okay, so that was a bit of a diversion, just to make things look pretty.
Yeah.
It's important though, because we need to see what's going on. So what do we want to do now then? We want to test doing substitution in a function, right?
Mm-hmm.
So we've got I and we've got I. Right, can we pretty print I? I'm going to look at everything. So I dot pretty print. Okay, now what happens if we do make sub in that function? Yeah. So let's say we want to substitute x with y. Yeah. Now no, this is actually wrong because we're not doing alpha conversion. Yeah. So this is what we've asked it to do. We've said don't mess around changing the variable name, but make the substitution in the body itself. So to do
With alpha conversion, would you also be changing the variable name?
What would you actually do here? With alpha conversion, you would, before you do anything, you'll check, is the substitution I'm being asked to make going to mess up stuff that's already there? So you can see in this case, this isn't the function that takes x and returns x. It's actually the function that takes a thing and returns the same thing. Yeah, and it doesn't matter if you call that x or y or z or Fred. It could be lambda Fred that returns Fred. So with alpha conversion, if someone asks you to go around changing your x's, the first thing you do is say, is x free or bound? And if it's bound, then you need to go and rename all the x's before you do the substitution.
Okay.
Okay. So we're deliberately not going to do that because it's faffy. Not hard, just faffy. Yeah. Okay, so that is just about doing what it's supposed to do then, up to alpha conversion. So we can also make that substitution on the bigger function, yeah? So this is the function IY we defined. Oh, and this is getting really messy now because we've got x's and y's and z's floating around. So look, at this point, I'm now swapping my x's for z's and leaving the y's as they are. Yeah?
Yeah.
So that's also looking sensible. Up to half a conversion. Yeah? Okay. So what do we want to do last then? So the substitution, we should test it on an application as well, right? Let's look at that application A. Pretty print. Okay, there's an application. Let's test. If you're doing this for real, all these tests that we do like this, we're then going to cut and paste them into our unit test file, and we're going to assert that that thing always equals the thing we've just printed. Yeah.
Are we going to need a unit test file for the report, or?
It's probably overkill.
Thank God.
It may actually help you stay sane while you're writing the thing, but I'm not going to do it right now. Yeah, not a requirement at all.
Yeah.
Okay. Good. So what are we going to do now? Let's take a look at that application then, right? So this is the identity function being applied to y. Yeah. So what happens if we run a make sub on this one? Let's say we take all the y's and we're going to replace them for z's. Yeah.
Mm-hmm.
So that appears to be behaving properly. Now just note again, if I do a swap an x, and I'm going to get the alpha conversion problem. Yeah, because that's supposed to be the identity function, but we know about that. That's okay. Okay, so make sub all seems to be working. So now let's think about actually performing an application. Yeah. So how are we going to do this? Simplest one we've got is the identity function. Yeah. Let's try evaluating this A expression. So A is going to take the identity function and make an application with the Y. Yeah. Or rather, that's what A is. A is an application of I to Y. And this is supposed to. What's it going to do? Okay, this is going to pass the buck on to the function itself. Yeah, we're saying the identity function is a thing. We're going to tell the identity function to go and evaluate itself using this argument, which in this case the argument is y. Yeah. And then that's supposed to go up here and say it's going to take the body of the function and it's going to go call make sub. Yeah.
Yeah.
So there we've got a dot eval pretty print, and there you go. That's almost a working Lambda interpreter. Actually, yeah. You just need to fix that. I'll put the Python code for that on Blackboard if anyone wants to play around with it.
I'll probably have a look at it, but I will. I'll give a go writing it in C# and see how that works. I think just see what happens.
Yeah, good.
Oh, but thanks for that. That was really helpful.
That was surprisingly fun. Don't often do live coding in these things. So good reason. Yeah. Anyone else want to ask anything while we're here? I'm not doing any more live coding. make the most of the glory while it lasts, because it doesn't usually last for very long. I guess the main thing we need to figure out is this VCC issue, right? We are quite dependent on VCC actually holding up. As I said at the beginning, always use the universal fix-it algorithm and start with something that you know that works and add little bits to it. And you can tell if it's the system that is slow or if it's your problem, because it has these Hello World programs, and if Hello World still works, then it's going to be your problem. But if it is the system, then we're going to have to find something else to do, because we have to submit these assignments. So anyone feeling clever could try and figure out how to run VCC locally. It is there on GitHub probably, but it is there in a very Microsoft-centered manner. So I know nothing about how to make that run. I think it's written in C#, I think. So if you like C#, it's maybe one for you.
I believe it's actually written in F#,
Oh God.
which is like
Really?
a super functional version of C#.
F# is roughly ML, yeah. It's a kind of Pascal ML type system.
It's very functional. I would not degrade those languages as far to say that they're equivalent to F#. They're much more beautiful than F# is.
So yeah, I've not gone in the detail. I could see there are a bunch of .cs files, but yeah, if the meat of it is F#, then have fun with that as well. If we can't get it working, then we're going to have to go and find something else. Yeah,
it wasn't working when I ran it, when I did all the stuff now. It was working last night, and it appears to be working now as well. So, for example, the hello world, it took like 10 seconds or so, but it successfully, the hello world is supposed to not be verifiable because you don't initialize it with anything, but it worked. It returned something. It told me that it wasn't verified. Oh, they couldn't verify it.
Yeah. Okay, good. So look, I'm not going to give out any reading this week because this weekend, next week's lectures are mostly fun and reinforcement and are not very examinable. And it's more important now to get these assignments done. So please focus on the assignments. Next week, I'm going to talk a bit about programming language design. I'm going to talk about semantics and type systems. And how these logic ideas show up inside programming languages. So again, not very examinable, but it's a nice way to reinforce the stuff we've already learned, to see it as an example. So yeah, please focus on the assignments. Please bring your assignments for us to have a look at next week. I'll see you then.
Cheers.
Bye-bye.
Thank you. Thank you very much.